So in this question here, we're going to look into binomial distribution and the critical regions when doing a hypothesis test. Now, we've set up a hypothesis test here that the standard probability of success is 0.3, but there is some suggestion that the probability of success is not actually 0.3, but we don't know if it's higher or lower. So this is going to be a two-tail situation by this inequality sign in the middle, where it says it does not equal. So it's a two-tail situation. So our critical regions are the lower bound and this upper bound. Now we're going to do 30 tests, and the distribution for the binomial in that situation will be x is distributed binomially 30 tests with a probability of 0.3, and the test is to 5% significance level. So that means we want 2.5% or less in each of these critical regions. So 2.5% or less. So that's in either tail. So that will give us our 5% in total. So now what we need to do is to set up our test statistic. So what we need to do is use the binomial cumulative distribution. So binomial cumulative distribution. So that will give you probability x is less than or equal to some value k, for example. So now what we want to do is put in some values and try and estimate what this lower tail's boundary would be. So we're interested in which figure that would be, and as it's the binomial distribution, they will be whole numbers. So what we have to do is we have to plug in a value where we think it might be, and then work from there and see where we can do, a bit like a trial and error. So that's a suggestion for this video. So here I'm going to try 4. So probability x is less than or equal to 4. So the binomial cumulative distribution here, you'd have n is 30, p is 0.3, because that's our distribution, and this value here for the k, any calculator, it probably comes under x, depending on what calculator you've got, so you put number 4. So if you type all that in the binomial CD function, you'll get approximately 0.032. So 302, sorry. So that's what you would get for that. Now that is just over 3%, but that's a little bit too big for our 2.5%. So that would come about here, which is outside of our critical region. Here you would accept the null hypothesis. So now we want to try maybe the next one down. So x is less than or equal to 3. So there, let's put that in our calculator and work it out. This time, same first two numbers with n and p, but this time try x is 3. If you do that, it will come out at approximately 0.0093. So that is quite a big jump. That's now less than 1%. And that falls in within our 2.5% critical value. So therefore, in the lower tail, that would then mean that this value here is going to be 3. So that's going to be our rejection region. So that's where we reject the null hypothesis. So reject the null hypothesis. Okay, so that's our lower bound. Now we need to have a look at our upper bound and see what numbers we can get for that. So now we want a different situation where x is greater than a number. So with this, if you type that into your calculator, and let's try our calculation starting from 14. So what you do in your calculator, you'd use that, because 14 is included for x is greater than 14. So your calculator will calculate x is less than 13. So for your calculator for these ones, you'd have n is 30, p equals 0.3, and x equals 13 for your first calculation. So type that in your calculator and you'll get approximately 0.0401. And again, this one is 4%, so that's slightly too big for here. So 13 would be around about there. That's no good to us. So let's try the next one. So probability x is greater than or equal to 15. In which case our calculation would be 1 minus probability x is less than or equal to 14. So same as this, but you just type x is 14. So that will come out to 0.0169. And you can see that's just over 1.5%. So that's ideal for us. So probability x is greater than or equal to 15 falls in our critical region. So that means that this value here is going to be 15 on that line there. So that's going to be our critical region, so including these lines here. So our critical region is going to be from 0 to 3. So let's do it as a square bracket so it's included. So 0 to 3 and in union with 15. Now what's the maximum value? Well, as we're doing 30 trials, the maximum value is 30. So that's our critical region, and any whole number inside those values will be a critical value. Now we want to find out what is the actual significance test value. So the actual value of our significance test. So I just write it like that for short, significance test. So with that, we want the sum of the extreme values that are in our rejection region. So we want the probability of x is less than or equal to 3 plus the probability x is greater than or equal to 15. So using our calculations on here, so x is less than or equal to 3.0093. And then this one is 0.0169. So put that in there, you get 0.0262. So 2.62%. So that's our actual value of our significance, 2.62%. And that's an introduction on the binomial distribution and its critical regions. Okay.